Welcome back to the Automation Podcast. My name is Shawn with the Automation Blog and School. And this week on the show, I meet up with Mark Arnold from SMC to learn all about their new air management system. Now, if you do enjoy these episodes, please consider giving us a like, a sub, and sharing it with your colleagues. It really helps us grow our audience and find new vendors to come on the show. And with that said, I also want to thank our sponsor who made this show possible, theautomationschool.com. They underwrote our production costs to produce this episode. And so if you know anybody who needs PLC, HMI, or SCADA training, please send them over to theautomationschool.com. And with that said, let's go ahead and jump into the show. Mark, thank you for coming back on the Automation Podcast. I am looking forward to learning all about this new air management system. We talked about it offline. It just sounds awesome. So I think the audience is really going to like it too. But before we jump into your presentation, would you mind taking a moment just to tell the audience who you are?
Sure. I am the electronic product sales manager for SMC, responsible for the US and Canada. And it essentially is all of our electronic product lines, anything that we make with a circuit board, just about. So our instrumentation, our valve interfaces that use field bus, our electric actuators. And really, this new system is a combination of several products, and I think it's very unique in the marketplace. So with the air management system, one of the main things we want to focus on is sustainability and how we can reduce our carbon footprint. So our sustainability, we're going to work with digitalization. And with the Sustainable Development Goals, there are 17 recognized goals for the globe. And SMC is really working to contribute toward those. One of the things we do, we support the 5 Ps with the 4 initiatives. The 5 Ps are people, peace, prosperity, partnership, and planet. SMC has established 4 targets. Those are sustainable measures to prevent climate change, healthy and safe working environment, human resource development, and diffusion of automatic control technologies for the development base, and social contribution activities. So SMC has actually assigned people for each of these targets. What we're going to talk about today is more, of course, on the technology side. We're going to have a plan to do so. We're going to look at how we do the PDCA method, so the plan, do, check, action. So we're going to reduce air consumption. We're looking at how we save the energy that way, and other methods that we measure the energy savings. We consider everything, more of a holistic approach of how compressed air is used in a facility, whether it be air blow, leakage, calculation of the air blow, vacuum generators. So anywhere that we're using air, we want to look at how we save energy. The SMC could save the energy and reduce costs and cut carbon emissions altogether. So for a little bit more information, here's a QR code to talk about sustainability. One of the newest things we've introduced, of course, is the air management system. The air management system uses a methodology to reduce compressed air. We monitor it and look at that efficiency. The AMS is specifically designed to be equally implementable for both new machines and in operation machines, referred to as a greenfield and brownfield, respectively. So with this, we have a built-in OPC UA server in addition to common industrial network protocols. So we're looking at how we can automatically regulate and compress and isolate compressed air to a machine. The data resolution is pretty good too, so we get very granular measurements of what's going on in the machine. So again, the 3-in-1 solution of sustainability, so we can reduce pressure automatically during short or prolonged phases of non-production, so we can reduce air consumption and CO2 emissions. Predictive maintenance, we can actually use the pressure, flow, and temperature data to establish baseline conditions for machines and other air consumers. And we can understand the operating conditions, and if they change, we can take preventive action. Digitalization, so the air management system provides, again, high-resolution data, enabling the benchmarking of machines at factories. Users can compare machines to learn from them. So if you're an OEM, you can look at your machine in one facility, benchline it, and then see how it works in another facility and take appropriate action for improvements, or to tell the end user how to operate that machine more effectively. So we have 2 different versions of the air management system. One has an electronic regulator and one has a manual regulator and a shut-off valve that also has a soft start included. To give a little bit more of a breakdown between the two, I'll show you here. We have the hub, the data system that actually pulls in the data on the air management system. There's the hardwired version that communicates back to the PLC either through Profinet, Ethernet IP, or EtherCAT. Simultaneously, it has an OPC UA server for the Ethernet IP and Profinet versions. Now, there's also a wireless base unit built into the wired hub that will communicate up to 100-meter range with other AMS hubs. These other hubs will not have the OPC UA server or a hardwire connection, but they can communicate back to the main base hub.
Hey everybody, just a quick sponsor message here to thank theautomationschool.com for underwriting the cost to produce this episode with SMC and Mark Arnold. If you know anybody who needs PLC, HMI, or SCADA training, please send them over to theautomationschool.com. And with that said, let's get back to the show.
They also have 4 IO-Link connections on the back of the hub. 3 of those 4 are already consumed, and we'll talk about what those are for. And we can do this AMS in 4 different sizes. So we have 0 to 500, 0 to 100, 0 to 2,000, and 0 to 4,000 liters per minute. So depending on the system that you're going to use, whether it's a large system with large consumption or a smaller system with a 1/4-inch port, we have some options available for those different sizes. Again, they have the electronic regulator and the manual regulator. So this is giving you an idea how the unit works. So the first question is, can you shut off the air supply? If the answer is yes, then I'm sorry, let me start with no, because this direction is more common. If the machine can go to a standby mode where you keep some residual pressure, then you signal this to go and lower the pressure through either the manual regulator set point through a solenoid valve or through the electronic regulator to reduce pressure. To explain this a little better, look at if your normal pressure is 80 psi in your equipment during normal operation, yet if your operator goes to lunch or there's a machine stop for an extended period of time, you can activate the AMS with a single digital signal. It will then look for a flow reduction that indicates that the machine is not in the current operation state, and it will activate the standby mode where it reduces pressure to a preset point, let's say 30 psi. So you don't completely eliminate pressure, but you do reduce that pressure, maintain certain devices that need pressure on them, but reduce that amount of pressure to reduce your leaks downstream. The other reason why you wouldn't completely eliminate the pressure is, of course, if there's something that needs to be held or some process where you need to cool or some kind of air purge. And if it's a short period of time, you don't have to bring pressure up completely from 0 up to full pressure. You're bringing it from a lower pressure up to full pressure. So that air that has been reduced is not completely eliminated and wasted by exhausting that residual air.
Let me ask a question here. So,
Yes.
Mark, let's say the operator on the machine, it's time for his lunch break. This system doesn't automatically go into standby mode. It needs an input to give it the okay that it could go into standby mode. So maybe he turns a switch or something that let the system know, I'm not going to be here. You can safely go into standby mode if it's called for. Now, how does the system know it's okay to go into standby mode? Is it just like the reduced flow because the machine's not using air anymore, so there's no flow? Therefore, it's like, hey, we're not using air. We can lower the pressure. Am I getting that right?
Yes, I think you're on the right track. So we don't want to automatically lower pressure because we don't know the process. We don't know what's critical in that process. So we don't want to use a downstream reduction of flow as the only signal.
Okay.
We want to have an external digital signal. It could be a timer, it could be a switch, it could be a pressure mat that when the operator leaves,
Mhm.
but we want that digital signal to come into the air management system. And then it starts a timer that looks for a flow reduction downstream that, yes, this machine truly has stopped, but it must have that external input first. And so we are not automatically reducing pressure without an external signal. It could be simple switch, it could be something in the PLC, whatever the owner wants to do, the operator wants to do. But we are not going to automatically drop pressure in the process because we don't know the process. So it's all set by the user, and it is settable through a web browser. So it is very simple to set up.
Now, if the operator comes back and forgets to turn the switch and he starts using air, will we leave standby mode automatically?
He has to actually remove that signal, that digital
Okay.
input, some way or another. So the machine would have some signal back to the PLC to know that, hey, it is in standby mode. So don't allow the machine to start up and operate on that lower pressure. So you would have a way to know that it's in standby mode. You would have that set up in that machine so it would not operate because it would not be at full pressure. So you have
Got
to
it.
remove that input to run in standard mode.
Makes sense. So it's very deterministic. Got it.
Yes, yes. And to further explain, again, we're not reducing pressure and completely and turning it off without, again, another signal. But the signal there can be internal. So we can go to the reduced pressure and set a timer. And they can say, okay, after 30 minutes, nothing's happened, the machine's not restarted. We can actually dump all pressure downstream if
Oh, all right.
that user so desires. And so then we completely eliminate leaks. This may be more the case of, hey, it's 5 o'clock on Friday, everyone has gone home. We've seen standby mode for a certain amount of time. Now let's go completely remove pressure so they're not blowing air all weekend long. And that's an optional setting in the web browser. And it's a timer that you can set for whatever range of time after standby mode has been activated. You can set another timer for what we call the isolation mode and completely eliminate air consumption by shutting off the air completely. Again, the other aspect of this, because that AMS base is communicating back to the PLC optionally, it doesn't have to communicate necessarily directly to the PLC. It can send the data through OPC UA server to whatever SCADA system or edge server or IoT gateway. So then you can take whatever data collection has been done through the AMS, you can send that up to the cloud for anybody's analytics. Because OPC UA is an open protocol, most major data processing software can take that data and process it. We don't want to be the gatekeepers of the data itself. We don't want to be the data managers or the data analytic people. We want to send the data, what's going on in the machine, and let the user decide whatever their particular architecture is, maybe Microsoft Azure, Amazon Web Services. There's tons of different analytic software companies out there. That's not our game. We want to make the hardware to interface and provide that data. As you can see on the left on the slide, we have remote systems that can feed back data back to the base. So you could have more than one of these air management systems on a line. With the 100-meter range, you're able to take that information back, maybe a complete line, and bring back critical data. One other thing about that, with those open IO-Link ports, you can put any IO-Link sensor back into it and read data. So it doesn't have to be the monitoring of the flow usage of the air system. It could be a current transformer that's plugged in with an IO-Link interface, and you can measure the current draw on the machine. You can put a vibration sensor in and read the data off the vibration sensor. Again, as long as it's IO-Link, it can plug in, and all that data can come back to OPC UA up to the cloud, and we can be the single point of information for the analytics. This is very useful, especially on an older system where you want to start monitoring it and you don't want to interrupt the PLC code that's already existing. You can put a lot of different sensing options on it and not disturb the existing code and will not have that risk. So you can start monitoring things and start making plans and data analytics again based on what you're seeing through that. We can monitor the energy real time too, of course. We can look at the air consumption and the kilowatt hours equivalent. So we can start looking at what happens during certain times of the day, certain types of production. We can start seeing what is going on and correlate those things back to production. It could be line stops, defects, and even OEE. So we can look at the overall operating efficiency because we can look at when the unit is in standby mode, we know we're not making parts. So that's a very timestamp sensitive data point that someone can look at and get a true OEE of the machine when they are not running the machine.
Hey everybody, just a quick break here for our sponsor. We're featuring their Mega Bundle product this week. It includes courses on Micrologics, Micro 800, Compact Logics, Control Logics, View SE, Panel View Plus, using CCW with VFDs, and more. And it's lifetime access for just one payment of $549. That's it. You own it forever. You can go through it as many times as you want, and you get lifetime support with it as well. So if you know anybody interested in PLC HMI or SCADA training, please send them over to theautomationschool.com. And with that, let's get back to the show.
We'll talk a little bit about a case study we did with an SMC partner. We did it over a 6-month period. That's still going on. So this is one of the early production units. We actually set this up and worked closely. We had an engineer on site working with them. It was actually on a bottle filling line with a line speed of about 180 bottles per minute. And we put 10 of our AMS devices on this line. It was very constant production, no changeovers. And we did this with the two different types, both the electro-pneumatic version and the manual set point. And we used 3 base units. We could use 1 base unit to 10 remotes. We just did it with the 3 just on this early testing. And we'll talk about what was required. We had the comms cables, so that would be the Ethernet IP type cables back to the PLC, and also back to provide data through the OPC UA server. We set up the IP addresses. We had to have the 24-volt power, of course. And with that manufacturing facility, we had to have a little bit of downtime to do the installation. And of course, we had a little bit of skill sets. We had to have the OPC UA connection and the field bus connection. And then we had to have that digital input signal. And that could be based on whatever logic required. In this case, since it was a consumer goods company, we also used the PAC-ML states. So you can probably see on this graph here, but we based the cost of compressed air on 0.0357 pounds per meter squared. So being pounds, that is, of course, the currency of England and the United States. So this is where this first test was done. And we did a CO2 emissions factor where we figured out 0.0665 kilograms CO2 per meter squared cube, excuse me, and that's the mass of CO2 emissions that is going on based on how much air you use. This is how much CO2 emissions that we are creating. So one bottling line had the 10 machines. You can see each of the machines hold up. The annual estimated square usage was over 10 million cubic feet of air. So that was quite a high consumption of compressed air. Once we installed the air management system, we dropped that down to 1.4 million cubic meters of air. This was all due to the standby modes and isolation modes. So how does that correlate to actual savings? If we put this into dollars, their current annual use of air cost them $81,000. And we had production mode maybe a little bit more than 50% of the time. Then we had standby mode, maybe a little bit more than a third, and a small amount of time in isolation mode. When we actually used the manufacturing facility with an AMS, the production timing was the same. Idle was quite a little bit of time, not very much. And then we had standby mode with AMS, and then isolation, we returned it completely off, went to about a third of the time. So that dropped the energy consumption cost down to about $58,000. So again, we dropped considerably the amount of time that air was being used, and we saved a considerable amount of money by reducing the energy and air by about 30%. That investment cost, the installation cost of setting these units up, installing all that was about $30,000, and we saved about $25,000 in compressed air cost. And of course, we reduced 39 tons of CO2 emissions. So we saved money and we reduced emissions considerably. So part of our digital sustainable ecosystem, we want to look at this as far as the main point where we're bringing in data and we're reducing compressed air usage, but we can do so much more with this. Like I mentioned earlier, we can start measuring current consumption, we can start measuring vibration, Anything that we can bring back through IO-Link, for example, we can start doing this, and you can start seeing this as the central data point. If you're an end user, this makes a lot of sense for your total factory consumption. If you're an OEM, start looking at how you can do some remote monitoring of the equipment, how you can help the end user out with predictive maintenance. Start looking at what works, what doesn't work, and really setting a footprint of your equipment. Maybe you can identify what the actual air consumption is so you can start looking at what you can do to improve your machine in the future. So these are all the things that we want to really look at, is how you reduce energy and how you monitor your systems. You can see what's going on and reduce our total carbon footprint.
That's interesting. Didn't you have an OEM who was upsell was increasing his warranty if the customers would buy this upgrade for the equipment?
That's exactly right. We had a couple OEMs where you're looking at this, and traditionally in our industry, Shawn, we know that OEMs want to produce a low cost but reliable system, and adding cost to their equipment normally doesn't make a good sell for them. But what they are looking at is if the system is installed on their equipment, now they can guarantee some uptime or have an extended warranty on the equipment because they know what that equipment was doing when it left their facility. They can work with the end user to monitor what's going on and increase the reliability of their machine by seeing those data points. And so then they can tell that end user, look, we know how this machine works. We know what we can expect out of it. And we can also, with your permission, remote in and see what's going on and let that end user make adjustments or some remote adjustments so that that equipment stays up and running longer. So this is a new paradigm for people, is to have a guaranteed uptime or even a guaranteed OEE. And this is one of the little pillars that they can lean on because they can monitor what's going on with their equipment and see what they can do to increase that reliability.
Yeah, and I know, most factories, most plants, energy is like the biggest cost, right? It's like such a huge number. And the price of energy is not going down, it's going up, right? So the days of maybe cheap energy where we can leave our conveyors and air compressors on 24/7, 365, that's today. That's really, really wasteful, right? Like just like we all insulate our homes now, we try to get the Energy Star devices when we're shopping, and we're looking for devices that are smart that we can schedule them on and off so they don't remain on when they don't need to be on. And we do the whole home automation. That's happening in our plants too. And products like this, and I think one of the things I would really like when we were talking in the pre-show about this, about the fact that this is not only going to um, help you with reducing the pressure when it's not needed, but also it has the Ethernet. You have Ethernet IP, you have Profinet, you have what was there a third
The,
one
the
that was
Ethercat, yes, Ethercat's the
Ethercat?
third.
So, I mean, those are like the 3 big guys right out there for the modern Ethernet networks, and you also have OPC UA, so, you don't even need a PLC, right?
That's
Like you
correct.
said, you could use OPC UA to go to the cloud or go to a SCADA system or even go to an HMI, right? I mean, it's a beautiful, and then you have the unit that has the wiring connection, but also can wirelessly talk up to a bunch of other units. So if you just want to have one wire drop in an area and then install these on multiple systems nearby, you only that's such a huge saving. I mean, wiring and every new drop is so expensive in a plant, right?
Yes.
So it really is a home run, I think, of a product, and the examples you give of the applications, and plus you get that extra IO link port on the back too. So, if you wanna monitor voltage or current or something else, vibration, that port's already built into it. So really, I think there'll be some interesting applications and uses on this. And I want to reach out to our listeners and say, you just listen to us talk for a while. Now it's time for you to talk back. Go to theautomationblog.com/talkback and send us any thoughts, ideas, your opinions. I will make sure they all get over to Mark. And but I'd love to hear, and we'll even do a little post-show episode if we get enough comments in. But if we would love to hear what you have to say, what your feedback is. So, and you can provide that to us via theautomationblog.com/talkback. And Mark, I really appreciate you coming on the show. Is there anything else you wanted to cover?
No, I don't think so. I guess one little addition is because you're doing so much, I guess, capability of monitoring. The flow rate, of course, is one thing you can change, look at and fingerprint the ideal state, and then look at deviation and changes. But if you really wanted to, you could get into things like, well, I can measure the position data of an actuator and look at did the speed of that actuator change? Did somebody change the speed control on that? And or is it starting to slow down? And again, this is some of that condition-based monitoring that you can do. So you can start looking at predictive maintenance and getting to the
Yeah.
point where, hey, now you know what's going on in that machine, and maybe the maintenance guy gets an email to go out and just make that adjustment versus somebody having to troubleshoot a machine. And of course the leaks and things that are pretty much part of the air systems that just happen because of wear. Those are things that can start being looked at, and not having to go out and do the ultrasonic checks. You can just say, hey, actuator B is leaking on the A port side, and then go and take care of it, and really before that machine stops. And so you're keeping a lot of data there that you can use, and it's as powerful as you want it to be, and you can analyze all of that. And there's so much is going on now, and with AI even, that can take that data and make those analytics without having to have somebody program it to every little detail. I think there's going to be a lot of change in the next 5 years regarding this.
Yeah, yeah. I can see like on a PLC side, I could sit, let, benchmark the system when it first goes in, build some alarms around some bandwidth, around some bands of, normal operating. And then if it ever gets out that I could alarm on it. But then if I was taking the data directly into a historian, I could just, throw up a chart. And I know we have so many aha moments in our careers when we look at a chart and we look at something over a long period of time. We're like, whoa, look what just happened to that. When it slowly changes over the days, you don't notice it. But when you look at it for over a year, you can be like, wow, that's really dropped off. We need to check on that and see what's going on with that. And that is where the AI and machine learning and a lot of these analytic packages are really starting to shine, as they do that for us automatically. They look for those deviations and can give us alarms and let us know that something's changing and we should probably look into it. So very good point, Mark. I appreciate that.
No worries. Thank you, Shawn. I really appreciate your time in this, and I'm excited about it. I'll be at Pack Expo next week, and it'll be a main feature that I'll be talking about. And it's definitely an exciting product for us, and I really think our customers and the audience here can see some of the benefits of it. And again, it's something we work with work with the customer on, and we can even do some trial runs at their facilities to let them see how it works.
Excellent. Now, for the audio audience, just so you know, you can learn all about this product. I'm going to give you the website. It's smcusa.com/solutions/applications/ear management system. So, if you want to learn more about that, go to that URL. And of course, the folks who are watching, it's right there on the screen. But Mark, thank you so much for coming on the show and introducing us to the ear management system.
Shawn, thank you so much as well. Look forward to our next conversation.
Well, I hope you enjoyed that episode, and I want to thank Mark for taking all the time out of his busy schedule to put that presentation together and come on the show and tell us all about SMC's new ear management system. Now, if you did enjoy that episode, please consider giving us a like and a sub and sharing the episode with your friends and colleagues. It really helps us grow the audience and find new vendors to come on the show. And if you want to follow me or get in touch, you can do so at our community website, automation.locals.com. You'll also find all of my training courses over at theautomationschool.com. With that said, I want to wish you all a very courageous, fearless, and awesome week. And until next time, my friends, peace.